Thank you guys for watching. I hope you find this key useful for helping you prepare for the quiz on solving systems of equations. We are going to go through these questions one at a time, and I'm going to do multiple methods to solve many of these so that we can see the difference between elimination, substitution, and graphing for the same type of question. We should be able to use all of those methods with each of these problems, but sometimes some of those methods are much easier than others. I'm starting with elimination on this one because we've got a pair right there ready to go for elimination. We have the same number, positive 2 and a negative 2. The positive and a negative will end up eliminating each other when we add them together. So we're going to add together both sides. We have a negative 1x and a negative 7x together get us negative 8x. The 2y and the negative 2y together are 0. And on the other side we have negative 11 and negative 13 get us negative 24 together. We can finish this out by dividing by negative 8. Divide by negative 8. We end up with x equals positive 3. We still need our y value, so we're going to take that 3 and we're going to plug it into the x value for either one of these equations. I prefer to do the one on the top because it's got some smaller numbers. So let's go ahead and plug that in and see what it looks like. So that would give us negative 3 plus 2y equals negative 11. Add that 3 to get rid of it. Add that 3 to get rid of it, or get it on the other side. So we end up with 2y equals negative 8. Divide by 2 to finish this out. And we get y equals negative 4. So our solution is 3, negative 4. We can do this in other ways. So let's take a look at substitution. This, in my opinion, is the easiest one to solve for to get it ready for substitution. So I'm going to do that by subtracting 2y on this side, subtracting 2y on that side. We end up with negative x equals negative 11 minus 2y. Get rid of that negative on this side by dividing by negative 1. Both of those need to be divided by negative 1. We end up with x equals positive 11 plus 2y. We can now substitute this in for x. We're going to do it in our other equation. So it's going to go right there. All right. That will give us negative 7 times 11 plus 2y minus 2y equals negative 13. All right, distribute this. We end up with negative 77 minus 14y minus 2y equals negative 13. Combine together these like terms here, we end up with negative 16y, negative 77 still there, and the negative 13 on this side. Add 77 to both sides to get those like terms together. We end up with negative 16y on this side, and over here we end up with positive 64. Divide by that negative 16, and we end up with y equals negative 4. And we saw that's the answer from the last one. So I'm going to stop here. If we were to plug that back in, we'd end up with the same answer. But I just wanted to show you that substitution will work as well. Let's try one more time with graphing. If we're going to graph, let's solve for this y. So we're going to add x to this side. We end up with 2y equals negative 11 plus x. Divide by 2. We've got to divide both of those by 2. We end up with y equals negative 11 halves plus 1 half x. Now this one's going to be a little bit tougher to do because right here our y-intercept doesn't end up in a nice spot. So I think I'm going to take a look at this and say, let's not finish this one out. It was clear to me that elimination was the easiest way. If we wanted to, and we are very careful with this, graphing will still work. Let's move on to the next one because this one, graphing does work the easiest out of all three. So we take our top equation, our y-intercept is negative 7. So we're going to go down here, 1, 2, 3, 4, 5, 6, 7. And we're going to put a dot there. And our slope is 5. We're going to do 5 over 1. So that means I need to go up 5. And that puts us at negative 2 and to the right 1. Up 5, 1, 2, 3, 4, 5 will put us at positive 3. And we go to the right 1 again. And that's our line for that top equation right there. Let's take a look at the other one. Our y-intercept is 6, so we go 4, 5, 6 right there. And our slope's telling us that we need to go down 3 and to the right 2. If we go down 3 and to the right 2, it puts us at this location, which we already had previously. And we see that that is our intersection right there. So the x value there is 2, y value is 3, so our answer is 2, 3. Now, graphing is by far the easiest one on this one because it ends up at a nice point, and our y-intercepts and slopes are nice to work with. So we're going to move on to the next example here, where we have this set up, and in my opinion on this one, elimination again was the easiest to do. And so we could either get these two to match up, or we could get these two to match up. We don't need to do both of them. So I'm going to pick the first ones, the x's. 3 and 4, we could get to both be 12. So they don't go nicely into each other. We're going to change both of them. We're going to change this one by multiplying it by 4. That would give us a 12x. And then we're going to change this one by multiplying by 3. That would give us a negative 12x for this equation. And that would set it up nicely for elimination. And we need to make sure that we do each term with that same thing. So we need to multiply this and this as well by 4. That'll finish out our top equation. That would give us plus 24y. And on the other side, we end up with 40. Down on the bottom, we have negative 12x. We need to multiply this and this also by 3. That gives us 12y. And over here, we end up with 24 times 3 is 72. So now we need to add these together. Positive 12 and the negative 12x end up being 0. Right here, the 24y, typo there, 24y and a positive 12y end up being 36y. And over on the right-hand side, we end up with 112. We finish this out by dividing by 36. Divide by 36. That ends up being not a nice number. That's all right. Our y value right there, if we round it as a decimal, ends up being 3.1 for that. So at this point, we need to plug it back in. So let me erase some stuff, and we will figure out our x value from here. So I like the top one in this case because I don't have to deal with as many negative numbers. Again, these will work in either one of these y's, so you can plug it in the top or the bottom. Plugging it in the top, that would give us 3x plus 6 times 3.1 equals 10. Okay, 6 times 3.1 would give us 18.6. We get 3x plus 18.6 equals 10. Get rid of that 18.6 by subtracting on both sides. That'll give us 3x equals negative 8.6. And we finish this out by dividing by 3. Again, that's not a nice number. That's okay. You can round it as the decimal, and that would give us negative 2.9. You could also leave these as fractions. Either one would be fine. But now we have our x and y values. Awesome. If we were going to use substitution on this one, I would have solved for either of these because the 4's work nicely with the 24 and both of the 4's here. So I'm not going to do the substitution all the way, but just to show you how you would get it set up if you chose to use substitution on this one. Let's go ahead and solve for this y right there. So I'm going to do that by adding 4x, adding 4x, and we have 4y now equals 24 plus 4x. Divide by 4, divide both of these by 4, and we end up with y equals 6 plus x. That's nice to work with. So we take that, we're going to plug it back into the top equation there. That would give us 3x plus 6 times 6 plus x equals 10. Distribute this, we end up with 3x plus 36 plus 6x and 10 on the other side. Let's get rid of this 36 right now. Subtract the 36. We end up with 3x plus 6x equals negative 26. Combine those like terms to finish it out. That'll give us 9x equals negative 26. And we can finish this out by dividing by 9. And when we do that, we end up with our x value of 2.9 right there. So we can see that this would work out as well. We'd have to plug that value back into one of these equations for our x value, and we'd be able to find the y value from there. I'm not going to do that because we just did it in our last one. I would not do graphing on this one because if it doesn't have nice values, the two solutions right here, 3.1 and negative 2.9, the two values would be very difficult to see on a graph. And so on this one, I would not use a graph unless I was able to use a graphing calculator or some electronic app that would allow me to be more accurate than I would feel confident doing by hand. Question number 4 is ready to go, set up for substitution already, so that's the method that I'm going to choose to use first on this. The y value is equal to negative 3x plus 5, so we can replace the y in the other equation with that value. When we do, we end up with 5x minus 4 times negative 3x plus 5. And over on the other side, we have a negative 3. We need to distribute to be able to get that out of parentheses. We end up with 5x. Negative 4 times negative 3x will end up being a positive 12x. And then negative 4 times 5 is negative 20. Over on the other side, we have a negative 3 still. We can combine these like terms, get 17x minus 20 equals negative 3. We'll add 20 to get that on the other side, and that will get us 17x left on this side and positive 17 over on that side. Finish this out by dividing by 17, and we get x equals 1. Now we need to plug that back in. We're solving for, we need to get our y value still, so the top equation is going to be easiest to plug it into since it's already solved for y. So we'll do that. We get y equals negative 3. Multiply that by 1 plus 5. Negative 3 times 1 is negative 3. So negative 3 plus 5, and that will finish us out. We have y equals positive 2. So our solution on this one, x is 1, y is positive 2. If we want to use elimination on this one, we need to do some rearranging. This 3x needs to be over on the other side so it lines up with the x and the y in our other equation. So if we want to do that, we need to eliminate the 3x on this side. We can do so by adding 3x. Whatever we do to one side, we'll do to the other side. So we add 3x on this side. That will get us positive 3x plus y, putting them in that order to match the order of the other equation. And over on the other side, we have 5 left over. So now, the bottom equation, 5x minus 4y equals negative 3, lines up with our variables in the top equation. Nothing matches up yet, so we have to get them to match for elimination. These, I think, would be the easiest. Turn both of those into a positive and a negative 4. So we're going to do that by multiplying this by 4, which means we need to multiply this also by 4. And we need to multiply this one also by 4. All right, doing so gives us 12x positive plus 4y and positive 20 on that side. The bottom equation we're just going to rewrite because it's already like we want to. 5x minus 4y equals negative 3. And now we can see with a positive 4y and a negative 4y that those are going to eliminate each other. So let's finish this out by adding them together. The 12x plus the 5x ends up giving us 17x. Over on this side, we have 0 when we add those together. And on the right-hand side, we have 17. So we end up finishing this out by dividing by 17, and we get x equals 1, which is what we got on the last one. We're not finished. We have to plug this back in like we did before, but that step is exactly the same as what we did on the previous one, so I'm not going to do it again. All right, on this last one, graphing, I don't think I would use graphing on this one. It works really nice for this equation, but on the bottom equation, it's not going to work out so nice because eventually we're going to have to divide by negative 4 to solve for the y, and this does not divide nicely by negative 4. So our y-intercept for that reason, is going to end up being in kind of an awkward spot for us to be able to graph. It would make it tough to see where all of the other points are as well. So graphing, I would not use this on this one, although if you had a graphing app, graphing calculator, it would make it a little easier. Let's finish out the last one right here. We need to write some equations. Our task is to find the price of a senior citizen ticket and the price of a child ticket. So we've got two variables. One of them represents the price for, I'm going to write SS for senior citizen ticket, except that's not SS. Silly Mr. Fowers. Senior citizen ticket. And we'll say Y stands for the price for child ticket. All right, we need to write two equations because we have two variables. So we take a look back here and we can see that we've got some totals here and some number of tickets that we bought. We can relate those to the price of the tickets that are our variables. So we sold on one of the days 5 senior citizen tickets. If I do 5 times X, that will give us our money for the senior citizen tickets. There were 4 child tickets, and so we add 4 times Y to give us the money for our child tickets. Both of those added together got us a total of $120. We can do the same thing now with the second day. $99, and we sold 2 senior citizen tickets and 5 child tickets. Let me just highlight those here. So we see 2 senior citizen tickets and 5 child tickets right there. All right, that would give us 2X for the 2 senior citizen tickets. That's the money we got. If I do 5 times Y, that would give us the money for our child tickets, and altogether that money was $99. So we have our two equations. This one I would use elimination on, because it is set up for that pretty well. I know that I can get the x's to match up if I turn them both into 10s. We need a positive and a negative as well. So we are going to multiply the top by 2. Multiply these all by 2. We end up with 10x plus 8y, 4y times 2, and 240 on that one. On the bottom, we're going to multiply that by 5, but we want it to be a negative 5 because that would give us negative 10x, and those would match up for elimination. That means we need to multiply this also by negative 5, and we need to multiply the 99 also by negative 5. So that would give us negative 5 times 5y would be negative 25y. And then on the other side, negative 5 times 99 is negative 495. This is now set up for elimination. Add them together, we get a 0 there. Love it. 8y plus a negative 25y together gives us negative 17y. And on the other side, we end up with negative 255. 255. Let's clean that up a bit. Finish this out by dividing by negative 17. And we end up with y equals 15. So that means it's $15 would be the cost of our child ticket. We can see that right there. All right, from here we need to plug it back into one of our original equations. So let me clean this equation up a little bit. And we could use either one. I'm going to go ahead and plug it in the top. They look about the same to me. So putting it in the top, we end up with 5. Oopsie there. All right, our y value is 15, so we end up with 5x plus 4 times 15 equals 120. 5x plus 60 equals 120. Subtract that 60 from both sides. We end up with 5x equals 60. And we can finish this out by dividing by 5. 60 divides nicely by 5, gets us a total of 12. So the child tickets Or no, those were the senior citizen tickets. The price for the senior citizen tickets was $12. So $12 for the senior citizen tickets, $15 for the child tickets, and we now have both of our totals. Thank you very much and good luck on the quiz.